Hi everyone, how are you doing today? I hope you're doing well and that you're staying safe. So today's lesson, we're going to graph trig functions again for one more day. And I know we've been doing it for several days, but I promise we are nearing the end. What we're going to do different today is we're going to use tangent functions instead of the sines and cosines, and just apply those rules that we've been learning to this function instead. So, remember, when you're going to graph, you need to find these four pieces of information from your equation first. Your amplitude, your new period, your horizontal shift, and your vertical shift. And remember the amplitude and vertical shift, the things that affect your graph vertically. Those are going to be the easiest to find because they're right in the equation. Your amplitude in this equation is going to be 2, the number in front of the your trig function, or that you're multiplying your trig function by. That's your amplitude. And your vertical shift in this case, because we have the plus 1 at the end, it tells us we're going to move up 1. Now your period and the horizontal shift, the two things that affect your graph horizontally, those do take a little more work. They don't just appear in your function. So remember, to find the new period, you set your bx equal to your original period for that function. And remember, tangent functions have a normal period of pi. We learned that back a couple class periods ago. So if you take that bx and solve for x, bx equals your normal period and solve for x, we get here that we are going to have a period of pi over 4. Now your horizontal shift is going to take a little bit of work too. What we're going to do is we're going to take what's inside the parentheses and set it equal to 0. And then we're going to solve that for x, and it will tell us how far our function is moving to the left or to the right. So here I get 4x is equal to pi over 2. I'm going to divide by 4, which is the same thing as multiplying by 1/4. There's no cross canceling that can happen here. We just multiply straight across, and we get pi over 8 is our horizontal shift. Okay, so what we're going to do then is we're going to graph again in stages and show you how we would find this function. So here's the first thing that I would do personally. I would I'm going to change my settings here so that we can compare it with my graph. Because my period is pi over 4, I'm going to take this from negative pi over 4 to pi over 4. And I know with my shift I'm going to end up being a little bit, it's going to all move horizontally within that, but I'm still going to use this as my domain for this graph that I'm looking at. Alright, now my y's, I have an amplitude of 2 and a shift of 1, so that means I'm going to need to go up at least to 3. Actually, tangent functions go on forever, so let's say maybe I'll take that from -6 to 6, something like that. I think that would be reasonable. And I am using radians, and I'm going to step my function by at least pi over 8, because that's what I'm going to need to use here. Alright, so with my tangent functions, normally they start in the center. You can go back and check your original function, and I'll even graph here just y equals tangent of x. It starts at the origin. So I'm going to graph something that has the new period and it has the right amplitude. So I'm going to start by graphing something that goes through the point 0, 0. And it's got a period of pi over 4, and what we do here is half of your function is going to be to the left of your 0, and then it's going to run into an asymptote. And half of your function is going to be to the right of your 0, and then you run into an asymptote. And then you're going to repeat the function on each side of that asymptote. Now, there are a couple key pieces, a couple key points here in this function that are going to be helpful. The first one is that point that's at the origin. Your tangent, when there are no shifts involved, is always going to start at the origin. And the second one is normally when you move halfway towards the asymptote, you have a y value of 1. Here, though, we have an amplitude of 2. So this point that normally would be here is going to be here instead. And likewise, when you move over in the negative direction, normally you'd be at this point -1, but instead we're going to be at the point -2. Once you have that, you can draw your function in. I did a poor job there. Now remember, that is only using my amplitude and my period. So what I did here was I graphed just the equation y equals 2 tangent of 4x. Now if I want to add my shifts in, I'm going to move all of my points to the right by pi/8, and I'm going to move everything up by 1. So this point here goes over pi/8 and up 1. This point goes over pi/8 and up 1. This point goes over pi/8 and up 1. And your asymptotes will just move over by pi/8. So my blue function now. Here has where my where my shifted function will occur. So if I go through and follow through here, that's going to be here. This point halfway through, let's see, let's take that back. I'm just going to add in another period over here to the left and to the right. Well, just to the left, really. So this point, I had neglected to put this point in. And to draw its graph in on the red. Alright, so now, if I take that point, move it over pi/8, up 1, move it over up pi/8, up 1, I see a pattern. Oh, I made a mistake there, didn't I? You guys didn't catch me again. Let's go ahead and erase. I neglected to put that up 2 because it does have an amplitude of 2. Okay, so I'm going to take all of those points. Let's see. Let's go and erase that one too. Okay, so I'm going to take that point over pi/8 and up 1. There we go. There we go. And we see your function. It looks something like that. Okay, so let's double check and see what that looks like. And I was off in a couple little areas, but not too bad. If I look at my function, I was able to graph roughly where they're at. And that's, again, that's all I want you to do.